Yes, good morning, students. Yesterday, it has been informed to you that the continuity chapter will be revised. Though it was conducted by your beloved teachers of mathematics in the month of May, simply, I won't revise it. So, with the help of the one question, I want to explain the basic concept as well as the other concepts also, okay? The question is like this, please note it. Determine f of 0 so that the function f of x defined by f of x is equal to 4 to the power x minus 1 whole to the power 3 upon sine x by 4 into log of 1 plus x squared upon 3 becomes continuous at x is equal to 0. Yes, students, the given function is f of x is equal to 4 to the power x minus 1 whole to the power 3 all upon sine x by 4 into log of 1 plus x squared upon 3 becomes continuous at x is equal to 0. The continuous function at a particular point, we want to recall it, though you have studied earlier. I will explain to you again. Before going to this continuity, just we have to recall one more thing, that is called limits of a function at particular point. Okay, the limit x tends to a, the f of x is exist when existing when the right limit of f of x is equal to the left limit of f of x at the particular point x is equal to a. Clear? The a plus and a minus, this is the real line. Okay, real line, set of all real numbers, you all know well, collection of real numbers means rational numbers and irrational numbers. So here the point A is on this line and there is a neighborhood of this particular point. The right hand side, that is what, a plus, and here left side a minus. The a minus indicates, that implies a minus epsilon. What is this epsilon? Where the epsilon is tending towards to 0. Very small quantity. It is very small, tending towards to 0. And the a plus, that implies a plus epsilon. That means where the epsilon tends to 0. In the books, might it have been given the word h. H tends to 0. Both the same only. Whatever the convenient symbol you want, you can utilize it. Okay. So the left limit of the function at the particular point is equal to right limit of the function at the particular point x is equal to a. This is equal to the what? Limit x tends to a f of x. Clear? Now, given function, given that f of x is a real function defined on, why I told about this real function, the domain of the function is in the subset of the real numbers. Okay, is defined on subset of real numbers. And if the f of x, the limit x tends to a is equal to f of a, First condition, limit should be exist. That is, the limit x tends to a plus f of x is equal to limit x tends to a minus f of x, that is equal to f of a. Clear? The function is continuous at a particular, real function is continuous at a particular point x is equal to a means the limit of the function at the particular point a is equal to value of the function at the particular point a. Correct? When the limit exists, right limit of the function at this point a is equal to left limit of the function at the particular point a, f of x is equal to value of the function at x is equal to a. This is the main concept. Okay. Now here particular, the function is continuous at particular point only I explained to you. Now what about the, suppose the function is defined in a closed interval a comma b, closed interval a comma b, or open interval a comma b, or a set a, subset of real numbers. So the same condition is applicable for all the points in the subset, yeah, where the domain, where the function is defined. That is called the domain. You know that domain, codomain, range, everything you studied in the 11th standard. Clear? So when a function is continuous in a closed interval or open interval, the function should satisfy the condition for each and every points of the domain, yeah, closed interval, yeah, the open interval, otherwise where the function is defined. Clear? So you have to keep this point in your mind. The function is continuous at a particular point x is equal to a if the limit x tends to a plus f of x is equal to limit x tends to a minus f of x, that is equal to f of a. This thing you have to keep in your mind. This is the basic concept already explained by your teachers. Now let us come to this point, this problem. Determine f of 0 so that the function f of x defined by f of x is equal to 4 to the power x minus 1 whole to the power 3, the whole upon sine x by 4 into log of 1 plus x squared by 3. You see, numerator 4x minus 1 whole to the power 3. Here itself product of three functions, that means same functions. What is it? 4x, 4 to the power x minus 1 into 4 to the power x minus 1 again into 4 to the power x minus 1. Product of three functions. Okay. Next, the denominator sine x by 4 into log of 1 plus x squared upon 3. The product of continuous function is continuous. And division of the function f of x upon g of x, or if the f of x and g of x are continuous, then the f of x upon g of x also continuous. The condition is continuous at x is equal to a. The condition, the g of x should not equal to 0 at x is equal to a. This is very, very important. Okay. So the product, if two functions are continuous, the product of two functions are also continuous. The quotient of the function is continuous when the denominator, the function which is in the denominator is not equal to 0 when x is equal to the given point a. Okay. So we studied definition of the continuous function at a particular point, yeah, in the whole set of points, and the properties, product, addition. So f plus g, this is also continuous. F of g of x, this is also continuous. So many things, it has been explained by your teacher in the previous class. Now, let us come here. The f of x is equal to 4 to the power x minus 1 whole to the power 3 upon sine x by 4 into log of 1 plus x squared upon 3. Before going to this problem, we have to recall some more points. Limits. Some results on limits. This is also very important. Without knowing this one, no meaning. We can't do anything. Simply you can write the question. We have to recall this also. Limit x tends to 0, 4 to the power, sorry, a to the power x minus 1 upon x. That is equal to log of a to the base e. Here it is useful for the first one. The function which is on the numerator. Now the limit x tends, this also you studied. Basic things. And tan x upon x, that is also 1. And limit x tends to 0, cos x is equal to 1. Clear? This is one, first one, and this is what, second one. Now, the third one. The three functions are here. Limit x tends to 0, log of 1 plus x, the whole upon x. This is equal to 1. So, students, recall it. Those who didn't study properly. So, one thing, without writing the annual examination in mathematics subject, you all passed. Very good. Congratulations. But you have to recall it again. Limit x tends to 0, a raised to x minus 1 upon x is equal to log a to the base e. In general, whatever the base is not given, that means it is understood that the base is e. Now the limit x tends to 0, sin x upon x, that is equal to 1. Now limit x tends to 0, log of 1 plus upon x, that is equal to 1. These three things, we are going to use it for solving this problem. So what else you have studied in that 11th standard? That is very, very important for solving the problem. You are getting more scores in CBSE examination as well as your competitive examinations. Okay. Now let us come to this one. Here it is given. First, the f of x is continuous. The given function f of x is continuous at x is equal to 0. That means the limit x tends to 0, f of x, that is equal to f of 0. So, if you find the limit x tends to 0, f of x, then automatically you can get the value of the function at x is equal to 0. Okay, now what is it here? Limit x tends to 0. The f of x, that is equal to 4 to the, sorry, limit x tends to 0, 4 to the power x minus 1 whole to the power 3, the whole upon sine x by 4, sine of x by 4 into log of 1 plus x squared upon 3. Correct? So now this is equal to limit x tends to 0, 4 to the power x minus 1 whole to the power 3 divided by x to the power 3. The small adjustment you have to do it. X to the power 3 divided. So for the compensation, you have to multiply in the numerator x to the power 3. Okay, the whole upon limit x tends to 0. The sine x by 4. The whole upon x by 4 into x by 4. Correct? Divided and multiplied. It has been compensated. Now, another one into log of 1 plus x to the power 3 upon 3. The whole upon x to the power 3. Then here also x to the power 3 upon 3. Clear? So 4x minus 1 whole to the here already we studied the limit x tends to 0, a to the power x minus 1 upon x, that is equal to log of a to the base e. Now let us come here. This is what limit x tends to 0, 4 to the power x minus 1 upon x whole to the power 3. Correct? Then what is the value? Log of the what is the a? A is the what? 4. So log of, so you all might have been noticed this question. So shall I remove the question? Board not visible the bottom. Okay. I will continue from the top. Okay, I remove the question. Okay. I'll start from there. Yes, the limit x tends to 0, the f of x that is equal to limit x tends to 0, 4 to the power x minus 1 whole to the power 3, the whole upon sine x by 4, sine of x by 4 into log of 1 plus x squared upon 3, x squared upon 3. Okay. Yes, now this is limit x tends to 0, 4 to the power x minus 1 whole to the power 3 divided by 3 and multiply by 3, the whole upon limit x tends to 0, the sine of x by 4 upon x by 4. You may feel that why instead of divided by x, why multiply x by 4? The quantity x tending towards the 0, that is a very small quantity. When divided by 4, again it becomes the very smaller quantity. That's whatever the quantity is in this portion, that means the radiant, the angle, that should be the same. Then only limit can be applicable. Correct? So for the comma here, limit x tends to 0, sine x by 4, the whole upon x by 4 into x by 4, then there is no change in the function given in the denominator. Now, log of 1 plus x squared upon 3. The same way here also x squared upon 3. Okay, x is a small quantity. While multiplying what upon, it may be because of that 0.1. For example, 0.0001. Yeah, for example, I have taken 0.1 for your convenience. It is a larger quantity compared to that x tending towards 0 is a larger quantity. While squaring, what upon 0.01. So smaller quantity. So the same thing should be done here also. X squared upon 3 and divided by 3, what upon 0.001 like that it is going on. Okay, very further it is decreasing. That's what the quantity should be same in numerator along with the function as well as in the denominator. Okay, now x squared by 2 multiplied by x squared by 3. Sorry. Now this is equal to limit x tends to 0, 4 to the power x minus 1 whole upon x whole to the power 3 into the x to the power 3 whole upon limit x tends to 0, sine x by 4 upon x by 4 into x upon 4 and limit x tends to 0, log of 1 plus x squared upon 3 the whole upon x squared upon 3 into x squared by 3. So here x to the power 3, before applying the limit, you have to reduce this x terms in terms of x. If you apply directly, what happens? X tends to 0. This becomes the what? log of 4 base e into 0. Then again what happened here? 0, 0, 0 into 0, 0, 0.0 indeterminate. That's what? Now here x to the power 3 cancel by x and x square. Now denominator 4 into 3, that is 12. 12 will be in the numerator. Now apply the limit. That is the word log of 4 to the base e. The whole upon 1. Is sine limit x tends to 0. Sine x upon 4 upon x by 4, that is equal to 1 into, and log 1 plus x upon x, that is equal to 1. Already I given to you. You have to recall, keep in your memory this formula. So that is equal to 12 times of log of 4 to the base e. If you want, you can write 4 to the power 12 base e. That's all. I hope that you understood the basic concept as well as this problem. Now, shall we go to some other problems? Basic concept clear, some formula recalled you. And before going to the next chapter is for differentiability. Differentiability is what? The combination of trigonometry and analytical geometry. These two chapters, your topics, your branch of mathematics has been studied in your previous class, 11th standard. Okay? So here, before solving the problem, some more trigonometric formulas also necessary. Now the second question, find the value of, any comment there? The completed, yeah, they're asking sometime. So the cube will also be there in numerator. Ah, yes, the cube is there, but in the denominator, x into x squared, x to the power 3, x to the power 3 upon x to the power 3 cancel. That is 1. Oh, that will not explain. Q will also be there in numerator. Yes, it is there. X cube upon x into x squared. X into x squared is the what? X to the power 3. X to the power 3, x to the power 3 cancel. Clear? So all of you have been noted? Yeah, already. And then next you can see in the word and record also. Correct? No? Okay. Anyhow, before writing the question, if you want, you can write it. Find the value of a for which the function defined by the f of x is equal to a sine pi by 2 into x plus 1 for x is less than or equal to 0. And here tan x minus sin x upon x to the power 3 x is greater than 0 is continuous at x is equal to 0. So a into sine pi by 2 x plus 1 comma x is less than or equal. That means the function is defined when x is less than or equal to 0 as a sine pi by 2 into x plus 1. Okay. The left limit a sine pi by 2 into x plus 1, and the function is defined at x is equal to 0, that is a into sine pi by 2 x plus 1. Clear? This concept many students they are forgetting, directly going without understanding. So already I explained to you, left limit equal to the right limit, that is equal to value of the function. Correct? But here you are the when the left limit, when the function, where the function is defined, when x is greater than 0. Yeah, that means right limit. So x is greater than 0 means 0 plus tan x minus sin x upon x power 3. And here the function, when x is equal to 0, the function is a into sine pi by 2 x plus 1. When x is less than 0, the same function is a sine pi by 2 x plus 1. Clear? Okay. Yes. Now, the f of x, let us consider the a into sine pi by 2 into x plus 1 when the x is equal to 0. So it is given that continuous at x is equal to 0. So nothing to worry about the left limit. Left limit to forget it. When x is equal to 0, that value you can find out easily. When you apply that the f of 0 is equal to a into sine of pi by 2. That is equal to a into 1. That is equal to a. Sine pi by 2, 1. So keep it as 1. Now let us come. The limit x tends to 0, right limit. The f of x is equal to limit x tends to 0, tan x minus sin x upon x to the power 3. Okay, now this is equal to limit x tends to 0. We all studied sin x, tan x is the what? Sin x upon cos x, simplify, and minus sin x the whole upon x to the power 3. So this is equal to limit x tends to 0. The sin x I can take outside and the cos x LCM. So 1 minus cos of x. Correct? LCM cos x. So sin x minus sin x into cos x. I have taken sin x outside. Then 1 minus cos x whole upon x. Clear? The whole upon x to the power 3. Now this is equal to limit x tends to 0. The sin x upon x, 1x I have taken, into the limit x tends to 0, 1 minus cos x, 1 minus cos x. Anybody? Off angle formula? 1 minus cos x is 2 times of sine squared x by 2. You already studied the sine of 2 theta, that is equal to 2 sine theta cos theta, and 1 minus cos 2 theta is equal to 2 sine square theta. When you apply the what formula, 1 minus cos theta is equal to 2 sine square theta by 2. So here x by 2. And x squared you can take here. The denominator x to the power 3, that is about 1x sine x upon x and x squared. So here the quantity is x by 2. So x by 2 the whole square, that is equal to x squared upon 4. Okay, 4 multiply and divide. This is 2. Okay. So now apply the limit x tends to 0, that is 1 into limit x tends to 0 sine x by 2 upon x by 2 the whole square into 1 by 2. Correct? So again apply the limit, that is 1 into 1 square into 1 upon 2. That is equal to 1 by 2. Keep it as 2. So from 1 and 2, what is the value of A? Here the function is continuous. The function is continuous at x is equal to 0. That means the limit exists. That's why I left the what? Left limit and directly gone to the value of the function at x is equal to 0 and the right limit. So now from 1 and 2, what is the value of A? A is equal to 1 by 2. Correct? Any doubt? Use present. Okay. Okay. Now, one more interesting question. Any doubt? Have you followed it? One more interesting question. Yes. Determine, very interesting question. Determine the values of A, B, and C for which the function, the f of x is equal to sine of A plus 1x plus sine x whole upon x for the x is less than 0. Left limit, when the x is less than 0, the function is defined as sine of A plus 1x plus sine x whole upon x. And now that is equal to C for x is equal to 0. That means the function is defined at x is equal to 0. The value of the function is what? The constant C. Now root of x plus bx squared minus root of x, the whole upon b to the power 3 by 2. Here for x is greater than 0. X is greater than 0. B x to the power 3 by 2. Sorry. B x to the power 3 by 2. Okay, if you find the value of left limit, yeah, right limit, you can get C. It is given the function is continuous. The function is continuous at the particular point x is equal to 0. When x is less than 0, the function is defined sine of A plus 1x plus sine x, the whole upon x. And when x is 0, the value of the function is C, a constant function. Now when x is greater than 0, the value of the function is root of x plus bx squared minus root x, the whole upon bx to the power 3 by 2. Okay, now let us take the what? Left limit, okay? Limit x tends to 0. When the x is less than 0, the function is equal to limit x tends to 0, the sine of A plus 1 into x plus sine x, the whole upon x. So this is equal to limit x tends to 0, sine of A plus 1 x upon x plus limit x tends to 0, sine x upon x. Otherwise, you can apply the sine C plus sine D formula. This will be very easy. Divided by the what? Cos x. A plus b upon c, that is equal to a by c plus b by c. Very simple. Yes. Now, this type of question already we explained. Limit x tends to 0, sine of a plus 1x upon a plus 1 into x into the what? A plus 1. Correct? And plus limit x tends to 0, sine x by x. This is equal to a plus 1. While applying the limit, this particular area, particular portion becomes a what? 1. 1 into a plus 1 plus sine x upon x, that is equal to 1. So that is equal to a plus 2. Keep it as 1. Clear? So now, when the function is equal, when x is equal to 0, the function f of x is c. That means the f of 0 is equal to c. Keep it as 2. Now, the limit when the x is greater than 0. When x is greater than 0, the limit x tends to 0. The f of x is equal to limit x tends to 0 root of x plus bx squared minus root x the whole upon b into x to the power 3 by 2. So let us see the numerator. That is the root of x plus bx squared minus root x. First we have to rationalize it. How to rationalize? Multiply both numerator and denominator by the conjugate plus root of x, the whole upon root of x plus bx squared plus root of x. Clear? So we already in the 8th standard, 6th standard, yeah, some study a minus b is equal to a plus b. That is a squared minus b squared. The sorts we study there also the conjugate of the particular real number, yeah, rational number can be rationalized. Irrational number can be rationalized. That you study. That's what teacher told. Beta a plus b whole square, a plus b into a minus b square minus b square, write 10 times. The punishment might have been given to you. Somebody done. So now it is very useful for to score the marks. Yes, now a minus b into a plus b square minus b square. So that is equal to limit x tends to 0, x plus bx squared minus x, a square minus b square, and b x to the power 3 by 2 into root of x plus bx square plus root of x. So a cancel. Yes, now this is equal to limit x tends to 0, x tends to 0, the b x to the power 2, the whole upon b x root of x. Correct? 3 by 2 means 1.5. That is equal to b x into root of x. Okay? And 1 upon under root of x plus bx squared plus root x. Okay, this is limit x tends to 0, b cancelled. So x squared the whole upon x root of x. Now, in this function, you can take root x outside. How? Root x take 1 plus bx. Multiply root of a into root of b. If both are positive, that's root of ab. So take inside what upon root x plus b into not root x while going there x inside the square root, that becomes the word x. and bx, one more x, bx square, and plus root of 1. Clear? So, now this is equal to limit x tends to 0, the x squared upon x square into 1 upon root of 1 plus bx plus root of 1. Okay, x squared cancel. Now we apply the limit 1 by 1 plus 1. That is positive value you can take root of 1, positive value 1, and here 1 upon 2. This is 3. So now the second one, yeah, the f of 0 is equal to c, and the third one, limit x tends to 0 plus f of x is equal to 1 upon 2. We studied limit x tends to 0 plus f of x, that is equal to limit x tends to 0 minus f of x, that is equal to f of 0. So let us come, yeah, 0 plus 1 by 2, and that is equal to a plus 2 left limit, that is equal to c. From here we got the value c is equal to 1 upon 2. Directly we can link it. Okay. So c is equal to 1 upon 2, one value over. Now a plus 2 is equal to 1 upon 2. Then what is the a? A is equal to 1 by 2 minus 2, that is minus 3 by 2. Correct? Now what about the value of b? Clear? If you want, you can go through one more time. I want the board to complete the question. Shall I clean this portion? When x is less than 0, we got the value a plus 2. And the limit x tends to 0 minus the f of x is a plus 2. Okay, I will keep as it is. Yes. Let us come to the function where it is defined when x is greater than 0. Yes, limit x tends to 0, f of x, that is equal to limit x tends to 0, x plus bx squared minus root of x, the whole upon bx to the power 3 by 2. So when the b is equal to 0, when b is equal to 0, what about the function? Yeah, the denominator of the function becomes the what? 0. Clear? That is one point, note it. The b should not be equal to 0, first case. Let us come here, the problem where we solved. Yes, here 1 upon root of 1 plus bx plus root of 1. So here the x is equal to 0, okay, root 1 plus 1. Yeah, the b is equal to 0, it's okay. But in the function, when b becomes 0, it invalid indeterminate. That's what the value of b is equal to. The value of b is equal to any real value other than 0. So or minus 0. So the answer is, you can write, you can make it make easy for the evaluator, your examiner. A is equal to minus 3 by 2, B is equal to R minus 0, and C, that is 1 upon 2. This is the answer. Yes. 10 more minutes left. Shall I give some assignment? Yeah, shall I explain? कभी-कभी आते हैं. I'll do some more. One more question. Today the class will be lengthy. Otherwise, also the mathematics physics for classes will be up to 1 hour, na? 1 hour classes. Okay. Clear? Yeah, you can see the record video also. Okay. Yes. Find the value of k if f of x is continuous. After hearing the continuous word, you have to recall immediately the limit, left limit equal to right limit is equal to value of the function at the particular point. Here x is equal to pi by 2, where the f of x is equal to k cos of x upon pi minus 2x when x is not equal to pi by 2. And here it is 3 when x is pi by 2. Okay, the value of the function when x is equal to pi by 2 is 3. It is very clear. Now we can apply any one of the limits. Okay, limit exists. So the limit, yeah, it is given that you can note it, given that the f of x is continuous. F of x is continuous at x is equal to pi by 2. That means limit x tends to pi by 2. That is equal to f of x. That is f of pi by 2. So it is given that is 3. Now let us find this value, limit of the function when x is pi by 2. The k f of x is equal to limit x tends to pi by 2 k cos of x the whole upon pi minus 2x. So here change the limit, okay? When you put y is equal to pi minus 2x. So when the x tends to pi by 2, when x tends to pi by 2, the y tends to 0. How? Pi minus 2 into pi by 2. That is 2 into pi by 2 is what? Pi minus y, that is equal to 0. Y tends to 0. Now we can apply. Yes, now that is equal to limit y tends to 0. Then what is the value of x? This implies, so 2x, let us take this side, 2x is equal to pi minus y. Y is equal to pi minus 2x. So 2x I have taken the left side, minus beyond the dot plus. 2x is equal to pi minus y. Then what is the value of x? X is pi by 2 minus pi by 2. Okay, now this is equal to k into cos of, what is the value of x? X is pi by 2 minus y by 2. The whole upon y. Okay, now limit y tends to 0. Cos 90 minus theta, sin theta, y by 2. And here y, the radian, the angle in terms of the radian, that is y by 2. So divided by y by 2 and multiplied by 2. Okay, now k outside, the limit y tends to 0, sine of y upon 2 upon y by 2, and this is k by 2. Correct? The 2 is in denominator. Okay, now apply the limit k by 2 into 1. Since the limit, in the very first question I explained to you, sin x upon x, that is equal to 1. Okay, that is k by 2. Now let us come, the limit x tends to, the function is continuous. Limit x tends to pi by 2, f of x, that is equal to f of pi by 2, that is equal to 3. That means k by 2 is 3. the value of k is equal to 6. That's all. Yes, students. 5 more minutes left. Shall we go through one more question also? No? Anyway, the first class of mine, some questions we explained, the basic concepts also recall. Anyhow, thank you, students. We'll see next class. Okay.